Patriot PAC-3 is a modern air and missile defense weapon that represents a major step forward in how a country protects its airspace and strategic assets. The original Patriot system was mainly known as an air defense system used to track and shoot down aircraft and cruise missiles, but the PAC-3 version is specifically designed to counter short-range and medium-range ballistic missiles which travel at extremely high speeds and come in at steep angles. This makes the job far more difficult and requires much faster reaction speed, smarter radar processing, and a missile that can strike with incredible accuracy. The PAC-3 missile does not rely on explosive blast to destroy the target. Instead, it uses hit-to-kill kinetic interception, where the missile physically collides with the incoming threat at high velocity and destroys it through pure impact energy. This hit-to-kill method is far more reliable against modern ballistic threats because it eliminates the possibility that fragments might miss the missile warhead and fail to neutralize it. The system operates as a network of multiple elements working together. There is the radar unit, which is a phased array radar capable of detecting, tracking, and identifying threats at long distances. This radar can track many targets at once and guide multiple interceptors simultaneously. Then there is the command and control station, where operators receive data, evaluate threats, and assign interceptors. The launcher units hold several PAC-3 missiles in vertical canisters that can be quickly fired when needed. Each launcher carries more PAC-3 missiles than previous Patriot versions because the PAC-3 missile is smaller and more compact, but despite its smaller size, it is faster and far more advanced internally. The missile uses high-speed maneuvering thrusters to make sharp adjustments as it closes on the target. This is necessary because a ballistic missile moves extremely fast and often changes trajectory during its descent. The guidance system must be incredibly responsive and precise. The PAC-3 uses radar seeker technology, which allows it to home in on the target during the final phase and make micro-corrections to ensure a direct collision. This technology reflects decades of innovation in missile defense research, where nations have sought ways to improve interception probability against advanced missile systems. During real combat scenarios, the PAC-3 has been used to counter tactical ballistic threats in various conflict zones. It has been deployed by the United States and several allied nations in regions where missile threats are common. The system has demonstrated the ability to track incoming missiles, separate real threats from decoys, and intercept them before they reach their targets. Success rates depend on many factors, including the number of incoming missiles, the angle of attack, and environmental conditions. But the PAC-3 continues to receive upgrades and improvements to increase its reliability and effectiveness even against more advanced threats. One of the major strengths of the Patriot PAC-3 system is its mobility. It can be transported by ground vehicles and redeployed to new areas fairly quickly. This makes it valuable for protecting moving forces or temporary bases. A fixed missile defense site can be targeted and overwhelmed, but a mobile system can reposition itself frequently to avoid detection and maintain coverage where it matters most. This mobility, combined with advanced radar and guidance technology, gives commanders flexibility and strategic depth. They can place PAC-3 units in layered defensive networks along with other systems like TOD or Aegis to cover multiple ranges and angles of attack. The PAC-3 also plays a role in deterrence. When a nation has a strong and effective missile defense system, adversaries must think carefully before launching attacks because the chances of success are reduced. This shifts the strategic balance. Instead of simply counting on offense to overwhelm the opponent, modern warfare now requires integrated offense and defense systems. The Patriot PAC-3 is part of this balance because it protects population centers, military bases, and critical infrastructure from sudden missile attacks. The heart of the system is still the radar, which detects and tracks threats. The phased array radar can scan large sections of the sky and focus energy precisely where needed. It updates target positions continuously and passes this information to the interceptors in real time. Radar data processing must be extremely fast because ballistic missiles move at tremendous speeds. The system cannot afford delay or hesitation. Every second matters. The PAC-3 missile uses a solid fuel rocket motor that accelerates it rapidly once launched. As it closes on the target, it uses its onboard guidance computer to compare radar data with actual movement and adjust course. The missile does not waste energy by maneuvering unnecessarily. It focuses all its energy on reaching and striking the target. When the collision occurs, the kinetic energy released is enough to destroy the incoming missile warhead, preventing detonation or disabling it before it can cause damage. This hit-to-kill method was a large advancement over older systems that relied on proximity detonations where the interceptor exploded near the target. That older method could work against aircraft or slower threats, but ballistic missiles are designed to be tough, fast, and compact. A near miss may fail to destroy the warhead, which can still fall and detonate. The PAC-3 solves this problem by ensuring the target is physically shattered through direct impact. Over time, multiple upgrades were developed like the PAC-3 MSE, which includes improvements to range, altitude and maneuverability. The MSE variant has a larger and more powerful motor and enhanced control systems to engage targets at greater distances and higher speeds. This extends the defensive envelope and gives more time to intercept incoming threats. Nations that operate the PAC-3 often integrate it into broader air and missile defense networks. These networks may include airborne warning aircraft, ground-based radars, satellites, and additional missile interceptors. The strength of modern defense is not in a single weapon but in the layered system where each part supports the others. The PAC-3 fits well into this structure because it is reliable, flexible, and proven. In training and live fire tests, the system is operated by teams of trained personnel who learn to coordinate radar tracking, target discrimination, and interceptor launch timing. Real-world missile defense is highly demanding because multiple threats may come from different directions or with different characteristics. Operators must identify which targets are real threats and prioritize them. The Patriot command system is designed to support these decisions quickly and efficiently. The presence of PAC-3 systems also sends a message to both allies and adversaries. To allies, it provides reassurance that missile threats can be countered, which strengthens defense cooperation and strategic partnerships. To adversaries, it signals that missile attacks will likely be ineffective and may provoke strong retaliation. This influences geopolitical decision-making and conflict planning. The Patriot PAC-3 continues to evolve as new missile threats appear. Hypersonic glide vehicles and maneuvering re-entry vehicles challenge traditional interception methods. Engineers continue to research improved sensors, faster processing, better propulsion, and advanced kill vehicle technology. The PAC-3 forms part of this ongoing progression and remains one of the core tools for defending against high-speed airborne threats. In summary, Patriot PAC-3 is a highly advanced air and missile defense system designed to intercept fast, high-altitude ballistic threats using hit-to-kill impact. Its radar guidance, mobility, and advanced interceptor missile make it one of the most reliable defensive tools available to modern militaries. Its success depends on precise tracking, fast decision-making, and kinetic impact technology that destroys the threat directly. It plays a key strategic role in deterrence, defense planning, and international security, and continues to receive upgrades to maintain effectiveness against emerging missile threats.